many countries. At one time, they were talking of low carbon economy, and they were talking of energy efficiency and water efficiency and resource conservation and so on. But today, the platform has moved way advanced to net zero building, on which IGBC has taken tremendous steps and have leaders working on this. And under the leadership of Mr. V. Suresh, this dynamism is really there to be felt by everybody. On top of that, the other topic that is also very relevant today is wellness. In fact, this evening there's going to be another session on wellness in buildings, because eventually whatever we do in terms of green buildings, it has to be people-centric and people must be healthy. So that's a different topic altogether. But coming to this net zero, in fact, in about another 20, 30 years, the buildings will be completely self-reliant. We are not going to be dependent on anybody else. We can produce our own electricity. We can be self-reliant on water by effective recirculation. We discharge nothing and we pollute nothing. And therefore, this becomes an ideal situation for the readdressal of the environmental problems. In fact, the pandemic itself, as you all know, has started, the biosphere in southeast of India, the Mannar estuary and all that, it's all improving. Air quality is improving all across the country. But what we have to do is we have to find ways to achieve this improvement to the environment while not restricting growth, development, and so on. That's where IGBC bridges the challenges. And I wish all of you to become an active member, because in the next 10, 12 years, 10, 15 years, when you're all the leaders of your profession, the students, you will have your hands full. And this is the starting of a thing, and it's in your hands to really make it grow and make India to the top. So with this, I wish the HOD all success. And I thank Dr. Shivraj Dhaka. I wish all the best to the students.
To start the session, it is about like 35 minutes presentation, and then we have kept some 15-20 minutes for questions. So shall we start now?
Yeah, please start. Yes.
Yeah.
Great. Please go ahead.
So, yeah, thank you, EASWARI Engineering College, for this wonderful opportunity to IGBC to have discussion on like net zero energy buildings. As you are aware, IGBC has a different type of rating system, and already it has been explained by Raghavendran sir. Now we would like to have a small presentation, and if you find any difficulty during the presentation or so, please feel free to disturb us so that we can have more discussion on that. Just a moment. I think some difficulty is there in sharing. Are you able to see my screen now? Vivek, are you able to see
Yes,
my
sir.
screen now?
Yes, yes,
Yes,
sir,
sir.
yes, sir. Perfect.
Please.
Okay, perfect. And now I have put screen on slide mode. So thank you once again to all the participants and especially the college for organizing this program. And we would like to understand more from you, like what are the new opportunities you may have in your university with regard to like net zero energy buildings. But before that, I will brief a small presentation. So actually, net zero energy building is one subset of the net zero momentum, which is now happening all across the globe. You will find lot many information on advancing net zero. And when we talk about advancing net zero, it talks about energy, it talks about water, it talks about waste, and finally there is a term called net zero carbon. And we are in the process to capture all different terminologies from energy, water, waste, and finally our goal is to achieve net zero carbon buildings. So already Raghavendran sir has mentioned about IGBC. For a brief introduction to all the faculty and students, those are not having much information. IGBC is part of CI and it was formed in 2001. The vision of IGBC is to have sustainable built environment for all, and India should have global position, global leadership by 2025. This is the vision for which IGBC and all the stakeholders are working together. So, as mentioned by Raghavendran sir, IGBC started in 2001 with own headquarter building, which achieved platinum certification in 2003, and it has very small green footprint of about 20,000 square feet. And today we have more than 5,900 projects all across the country, and it contributes more than 7.16 billion square feet of registered green footprint in the country. During 15 to 17 years, IGBC has developed different rating systems, and we are fortunate to have Raghavendran sir under his leadership. The first rating system was developed for new buildings, and he set the leadership for development of rating system for different typologies. So we are really thankful to Raghavendran sir and for his leadership in IGBC and in building movement in the country. After that development of rating system, IGBC with several chairmanship, several leadership from different sector developed 25 ratings so far, and you can find it out at number 6. IGBC Net Zero Energy Rating System was developed, and it was chaired by Mr. Ashish Rakheja. The rating was launched during Green Building Congress, and you can find it was launched by MOUD minister at that moment. And after that, it has gained good momentum in the country, and there are several projects which are going for net zero energy certification. And net zero energy certification is very important because it offers real tangible benefit to the project, and many of the projects they are able to save their operational energy cost as well as the total expenditure they have put on energy use in the building. So friends, when we talk about net zero building, we should understand the definition of net zero buildings. Net zero building are those which are designed and they are having the lowest energy demand, and during operation also they have a high energy efficiency, and after design energy efficiency and also having the operational energy efficiency, whatever the remaining energy is there, that would be met through the renewable energy sources. So a building which consume X amount of energy, and the building also generate X amount of energy from the renewable energy sources. When both renewable energy generation as well as the total energy consumption would remain same, then we call the building net zero energy building. And why we have developed the net zero energy rating system? So there is a story behind it. The whole globe is working towards advancing net zero. IGBC is one of the founding members of World Green Building Council. You are able to see the photograph here, and it sets some targets. You will find two targets here. One is like 2030, all the new buildings must be operating like net zero carbon, and by 2050 not only like new building but the existing building also will have the net zero carbon performance. This has been mentioned by Raghavendran sir very clearly, like after 10 to 20 years or so, maybe after like 2030 or so, all the buildings, they will never ever have any dependency on the fossil fuels, and they will be like highly resilient to the environment. They will have like climate responsive design. They will have equal amount of RE generation whatever they consume in the building. So when we have the equal generation and the generation equal to the consumption, then we call this building net zero building. So friends, when we are talking about net zero buildings, there are several policies, there are several energy efficiency requirements are set by Government of India, and IGBC is truly inclined to all these policies and regulation from the central governments of India. So when we design net zero energy building, our prime focus is to reduce the energy demand for a new building and also for existing building. There would be a lot of requirement for existing building to have deep retrofitting, and deep retrofitting is also a good research area for the institutes. They can also focus it on more. So if we talk about like energy efficiency, there are certain codes by Ministry of Power. One code is like Energy Conservation Building Code, which is part of Energy Conservation Act of 2001. Again, it has some amendment in 2010. So it improves energy efficiency in the building, and it is a prime duty for all of us to have the adoption of like Energy Conservation Act as well as the Energy Conservation Building Code, which is part of it. The other policies from the government of India are, there are several policies which India is working, and they are also having global impact on that. So one policy is like national mission for enhanced energy efficiency. These missions are also related, they are also inclined towards our global goals, and India is also part of like national body where there are policies are set. These policies are also inclined with like global norms like COP and many other things. The second thing is there is a solar policy, there is a solar mission from MNRE, and under which they have set a target to achieve like 100 gigawatt by 2022. So India has already achieved like 21 gigawatt till date, and there is a huge scope in that. So having this kind of buildings where we improve the energy efficiency, also address the national solar mission, definitely it will contribute to the growth of the country. So these are also having the market transformation to create a more and more demand for energy efficient building in the country. So if you ask about like what is the scope of net zero energy building, there is no restriction for the net zero energy buildings. Net zero energy buildings are applicable to any typology of buildings. It could be like commercial, could be like office building, could be residential, or any type of building which has sufficient solar system available over rooftop, or they are able to have renewable energy bill either through RE vendors or maybe through Discom, and they are able to offset 100% of the grid energy use by renewable energy sources. Then that building may go for net zero energy building certification. So with regard to applicability, it is applicable to all different type of buildings, and it covers all the typologies. Friend, this slide is very important. When we talk about green building, definitely we talk about like different areas like sustainable site, energy efficiency, water, building indoor environment quality, as well as the building material and resources. But when we talk about like net zero energy building, we are only addressing one component, which is for energy efficiency in the building. So when we talk about energy efficiency building, it is extremely important for us to address the passive measures. When we talk about passive measures, there are lot many technologies, and there are measures which can be integrated with the new building design. Suppose there is a new building coming up. Architect may have some different features like a buffer zone. He may create a dynamic facade for the building. He may give some more focus on the workstation. Workstation will be having more and more towards like north orientation and east and west, but it will be having list towards like south side, so that we are able to reduce the total heat gain for the building. When we are reduce the heat gain, it will also have the more energy efficiency, as well as it will reduce the air conditioning load. So there are many examples of like passive features, like some of the features which are very common in like old building as well as today's modern building is like providing shade. Many buildings, if we see the modern building which is in like tier 1 cities or so, today they don't provide like shade to the window or like glass, but it is extremely important. It is also part of like one of the passive measures. There is a good example of like orientation, what kind of orientation building should have, whether it should be like east west or northeast or many other angles, because it can be like 90-degree or 20-degree to east west or south or so. So these orientations are extremely important, and whatever the orientation we have set for the building, throughout the lifespan of the building, it will offer good tangible benefit to the project. We can take one simple example. If we put the building orientation in a right way, it may offer about like 1% saving, and in 1% saving, we have not contributed any other energy efficiency marks, or there is no investment for it. Only changing the orientation would reduce the energy consumption by 1%, and this 1% would remain for throughout the lifespan of the building. So it is extremely important to consider this kind of measures which are not having any investment. It is just like wisdom from the all the team members who are working on the project. The second part is envelope. When we talk about envelope, it covers wall, roof, and fenestration. Fenestration could be like opaque, it could be like transparent also. So when we talk about envelope, all these parameters, wall, roof, and fenestration should have some passive measures, and these passive measures should help to reduce the total heat gain, which is having some outdoor to indoor heat gain, and that heat gain would increase the demand of air conditioning. So these many things we should address first. And why we have given more focus on passive measures? Because whatever the passive measures we integrate in our building with regard to like orientation, buffer zone, or envelope or so, these would remain fixed with the building. It is hardly possible for us to change all these measures during the lifespan of the project. So when we integrate something which is part of design, it will help the building more and more. Friends, second task is to introduce the energy efficiency in the project and also to have the renewable energy, so that our total energy demand would be optimized further, so that it will offer more and more tangible benefit to the project. So under active measure, the first measure is like energy efficiency. Whatever the air conditioning, lighting, auxiliaries, or like appliances we use in our building, if they are so energy efficient, it would reduce our energy cost. And while reduce the energy cost, they are also giving benefit to reduce the first investment cost. So friends, you take one simple example. Suppose you want to purchase one AC for your bedroom or living room or so, and that AC is like 1 star rated, and the cost of AC is like 30,000. But if you purchase the five star AC, which is about like 45,000 is the cost, and the star rating is 5, and it is having like high energy efficiency compared to like 1 star rated AC. Maybe today we are finding a cost difference of like 15,000, but the life of the air conditioner would be about like 15 to 20 years, or sometime if it is more. When we consider the 20 years of lifetime for a product, and during this operation for like 15 years, it would consume lot of energy. So if we try to calculate the total energy difference between a 1 star and the 5 star AC for 15 years, we will find significant benefits as well as like operational savings in the project. So this kind of decision should be made when we are having the building design. If we integrate this kind of things, it will offer more and more saving for next 15 to 20 years when it is in operation. Similarly, you take some examples on like energy efficiency. Earlier, we used to have some incandescent bulb for all the lighting applications, and after that we had a transformation in the lighting. We used to had some CFL bulb, and this CFL would be about like 20 watt, 25 watt, compared to like a bulb of like 100 watt or 150 watt. It will have like equal lighting level in the room. But in recent time, we don't find any CFL, any incandescent bulb. We primarily use LEDs. So if you try to compare the performance of LED with regard to CFL or the bulb, there would be significant difference. Instead of like using the 100 watt bulb, you hardly use like 5 to 10 watt LED bulb. So that kind of transformation is already there in the market, and primarily that is there because of huge demand of this kind of fixtures. Similarly, there are a lot of practical examples, and there are policies from Government of India. They also rate different equipment like fan like motors, like pumps, or or a fan of like different type and size. So when we use this kind of star rated or the equipment which is having high energy efficiency, it will have more and more saving throughout the operation of these equipments. So whatever the passive measures we have introduced, it will reduce about like 10 to 15% of energy demand for the project, and remaining active energy which will be used by all these appliances or equipments. If we introduce the energy efficiency, definitely it would showcase about like 30 or 40% energy efficiency in the project. And if you talk about like energy conservation building code, which if we go for ECBC compliance, definitely it may reduce about like 40% of the energy. And this reduction in energy will definitely a operational saving for the project. Friend, the last example is when we have reduced the demand because of passive measures, we have put the energy efficiency in all the components with regard to like HVC, lighting, and the equipment. Definitely, it will lead more and more energy efficiency in the project. So when we have reduced the total energy demand of the project, there would be very less energy consumption for the project. It could be like some X kWh of energy. That energy should have offsetting through the renewable energy sources. So when we talk about renewable energy sources, there are primarily two sectors for it. One is called like on-site renewable energy. I think all of you are very much familiar about like on-site renewable energy. It is nothing but we are having on-site photovoltaic system. Our site or our building itself will have the renewable energy sources, and if we get some energy from these renewable energy sources, it will contribute to the energy efficiency in the project. The second part is off-site renewable energy. Off-site renewable energy is applicable where site or building areas are huge. You will find some commercial buildings like Capgemini or Google Office or Microsoft Office or Infosys or many other commercial buildings. So they do have high energy intensity in the project. Although they have put like good passive measures, they have introduced the energy efficiency. Even after that, there would be huge energy consumption for the project because they cannot put like 1 megawatt, 2 megawatt solar power plant there. They will have very limited roof, and the occupancy density would be high. They would also have the high energy intensity for every occupant also. So because of this, all the major projects, they need to have offsite energy. This means they may put one power plant which is away from the site, and that energy will be fed to the grid, and after that grid would supply back renewable energy power to the source company. Suppose your college has high energy use and you are not able to meet to on-site renewable energy application, you may put one power plant. Either you can invest it or some other vendors they can invest it, and that power can be wheeled to the campus. This is called off-site renewable energy, and there's a huge scope. I will explain during some of the presentation how off-site is helping the project to have better benefits. So friends, when we talk about like any green building rating system or any certification program, there would be some mandatory requirement, and there should be no compromise for all these mandatory requirements. Mandatory means if our building is meeting this criteria, then only we can go for net zero certification or maybe like green building certification also. So the first mandatory requirement for net zero is whatever the energy use is there in the building, similar or equal to that should be coming from the renewable energy sources. So this way we can mention like whatever the fossil fuel based energy supplied is to the project, same energy should come from the renewable energy sources. So when both are equal, it will meet the first mandatory requirement for going for net zero certification. The second part is when we calculate the energy efficiency in a project, there are some calculation process, and I think many of students and faculty they would remember about like energy performance index, which is nothing but if we have the total energy consumption of a building of your like home or like campus or of your college, and if we divide the total energy consumption by the area of the building, which is like built up area or so, then the ratio would be called energy performance index. So energy performance index will be calculated for any buildings which is going for certification. And while going for certification, EPI is calculated once for actual building, and this EPI is also calculated for a baseline building. When we talk about baseline building will have specifications from the code, and the applicable code for net zero is energy conservation building code. So friends, try to understand it. ECBC is the code. If we use all the specification from the ECBC, then we need to calculate EPI for ECBC. And similarly, we need to calculate the EPI for our building. If we divide EPI of our building, which is like actual case, so actual EPI divided by EPI of the ECBC specification, then it would be called like EPI ratio. And this ratio should be lower than 1. If it is lower than 1, this means our actual building, maybe like your college or so, it has better efficiency than the building code. And building code is like ECBC. The second mandatory requirement is whenever we go for net zero certification or any green building certification, the first and foremost important task is to provide good comfort conditions for all the occupants. Friends, net zero buildings, green buildings, they are not for some compromise in comfort for the occupant, because when we design the building, when we construct the building, when we operate the building, definitely our first objective is to have better comfort for all the occupants. So when we provide better occupant comfort, definitely there would be a good increase in productivity. I have several examples. If you increase the productivity of occupant by providing good comfort condition, their productivity would enhance significantly. And if you provide better comfort, their productivity goes up. The total resources saving would be much more, or we can say there would be lot more benefit to the project or to the client with regard to monetary benefits. So friends, it is extremely important to provide good comfort conditions. You can take one simple example. Suppose you are sitting in your office in the college, you don't have any comfort conditions. And comfort doesn't means like you should have the air conditioner there. Comfort means if we are able to achieve some comfort conditions with regard to temperature, humidity or air velocity, and that provides you a satisfaction with regard to like thermal environment, then we call it like comfort. And there is a huge scope with regard to like research on thermal comfort. I think some of you those are very interested in comfort, you may contact me, and we can also connect you with like some research institutes where you can participate in that. So this is the example like how to calculate the EPI. I think by now you have understood how to calculate the EPI and how we will derive the energy performance index ratio. I think these are the values, and these are the benchmarking indexes where all the institute may have more and more research. So when we are talking about like EPI ratio, it is simply actual EPI of the project. Suppose you have calculated the total energy use and you have divided by like built up area, then you will arrive the actual EPI. If you divide this actual EPI by design EPI, which is nothing but the EPI which we derive based on the specification of ECBC. This ratio would be called EPI ratio index. So this part we have already discussed, but we want to give some focus. Yes, like net zero certification provide about like 75% weightage on the energy efficiency, and about 25% weightage is given on renewable energy. There are different compliances, and this reference guide you can download from IGBC website. If you have any doubt, you can also ask after the presentation, after this webinar. But our prime focus is there are many compliance approaches. One could be like simulation based, where there would be expert who will develop the building model in computer, and once he puts all the specification of the building in the computer, he may derive estimated energy consumption of the building. So this is called like simulation approach. Similarly, he can also follow the prescriptive approach, where we don't need to put our mind, simply whatever it is mentioned in the guide we should follow for it. So this also talk about like what are the prescriptive requirements and how much weightage is given for like renewable energy. I think you can find it like renewable energy has about 25% weightage for this net zero energy certification program. It is much clear here, energy efficiency weightage as well as the renewable energy. But friends, we should not have any confusion. Like 70% weightage is given only on energy efficiency. This means only 25% remaining energy should come from renewable energy. No, it is not like that. The first definition for net zero is like total energy use should have equal amount of energy generation from the solar energy. Then only it may go for like net zero. But here weightage means if we have 100-point scale for net zero, 75 points are primarily reserved for the energy efficiency, and then 25 credit points, and we can call it like reward point, they are awarded based on the renewable energy used in the project. So when we talk about like renewable energy, already we have discussed like there is a opportunity for like on-site, there is a opportunity for like off-site energy also. So based on the project convenience, they may go for like on-site, they may go for off-site, they may also have the like combined renewable energy sources. Could be 30% on-site, 70% off-site also. I will have some slides on that, and I will showcase you like real-time examples. So friends, while going for net zero, it is a prerequisite like at least some 5% of the energy should come from the on-site, because there could be many projects they may have 100% off-site, and that off-site can be built to the project. So there would be some difficulty for this kind of project. So we advise like there should be some kind of photovoltaic system installed, or could be like small wind turbines should be installed for like renewable energy sources on site. So here I have some examples, and if you have any doubt, you can disturb me, you can interrupt me, and we can have more and more clarification there. So friends, this is our building in Hyderabad. Primarily, it was only a green building. It was the first green building in the country, achieved certification in 2003. So till 2018, it was like a green building having all the features implemented. And as you understand, whatever the equipment we put today, it may not have the same performance for like 20 years or so. So whatever the equipment or like air conditioning equipment which you can see in the like middle photograph, it was installed in 2003. It was one of the best high energy efficient water cooled chillers. And friends, if you are from mechanical energy or you are from energy background, you will understand it is very difficult to get a cooling system of like water based condenser for a smaller capacity. It is so difficult and so expensive. So this kind of chillers in 2000 were imported from US, but today this kind of chillers are also available in the country. So the last photograph on the right side, it is the photograph when we have retrofitted the complete air conditioning system, conditioning plant in our building. And when we retrofitted the complete air conditioning system, we improved the energy efficiency more than like 20 to 25%. So whatever the energy use was there for air conditioning, it was drastically decreased when we have retrofitted this plant. So when we have retrofitted, it has improved the energy efficiency for our building, but that is not sufficient to meet the net zero goal. So just to meet the net zero goal, we have put about 138 kilowatt peak solar PV system, and it is a unique solar photovoltaic system. It is not a general one, because this solar photovoltaic system is bifacial. Friends, you have seen so many solar photovoltaic system. They are laid down on the roof, and they will have one surface which will have all the solar radiation, and it will generate the energy. But friends, the solar photovoltaic system which we have put in our building now, it has bifacial. Bifacial means the front facade of the solar cell or like solar photovoltaic module and the rear facade, both are having the solar cell. When we are having the solar cell on both the side, the top side is getting the solar intensity or like solar radiation, and it is generating the energy. But what about the rear facade or like rear face of the solar photovoltaic module? So actually we have put this solar photovoltaic module about 1.5 meter height. You can see it here. This is the roof surface which is white painted. So solar radiation falling on the solar modules. Some of the radiation which is on the like ground or like SRA coated roof surface, it will have the diffuse radiation. This diffuse radiation would fall back on this surface, would fall back on the rear side of the photovoltaic module. So when this photovoltaic module is having 1.5-meter height, which is again a calculation for every project, it will have energy generation more than like 30% than a conventional solar photovoltaic module. So conventional photovoltaic module would generate about 4 to 5 unit per kilowatt peak, but the generation for bifacial would be about 7.5 to 8 unit per kilowatt peak. I think this is the basic difference. And what is the big advantage of using this kind of solar photovoltaic system? I think every building will not have sufficient space. If there is a space limitation, they want to have more and more energy efficiency in the project through renewable sources, then this is the only technology which can improve the energy efficiency, and in a small area it may have more RE generation. This is another case study which is Godrej and Boyce admin office in Mumbai. So friends, this is a good example just to understand what is called on-site, what is called off-site. So whatever the energy demand they have in this project, about 120 kilowatt of photovoltaic system has put there. It made hardly like 8 to 10% of the energy use. But rest of the energy, which is more than 90%, it is wind. Wind. Some companies they have put solar photovoltaic system in a big capacity like megawatt scale, or there could be wind installation in megawatt scale. From there, they are supplying to the grid, and this project is getting the renewable energy through the grid, which is billed to the project. This is called off-site renewable energy sources, and the terminal is called billing, so that there would be a transportation of the power from the solar to the grid, and that grid would supply to the project. So friend, this is combination, this is could be a combination of like on-site and off-site, where a project may aspire for like net zero certification. This is another example in Mumbai, which is a warehouse project. As you understand, warehouse project would not have high energy intensity. So in that project, which is earlier a green platinum certified factory, now they have achieved the net zero platinum also. So in net zero platinum, what they have done, they have put the 100% solar energy on the factory shed. I think you are able to see the factory shed where they have put the solar photovoltaic modules. So friends, earlier they had little capacity of like solar photovoltaic module, but for going forward under the net zero certification, they have increased the capacity, and now 100% of the energy requirement are met through the solar system, which is installed on the roof side of the factory shed. I think it is much clear. It is a clear case of like 100% energy requirement are completely offset by the on-site solar system. It is one of the like good examples for it. This is a very nice example where you can understand like very large size office building, or KPOs, BPOs, or the MNC companies. They have like huge occupancy,
Okay, sir.
and also they have the high energy intensity. How they can go for like net zero projects? I think in Chennai there are many buildings of like large size. Your some of like student as well as faculty members, they can be associated with like good companies to do some feasibility for some of the buildings, how they can achieve the net zero. You may also find it out like what are the design interventions, so that project may achieve a good certification level in that. So friends, for this project, it's a huge requirement for energy, and 15% of the energy is offset by renewable energy system, which is installed on the rooftop of all 10 buildings. And I think you should also look it here. The total energy requirement from this 15% on-site RE is more than 1583 megawatt hours per year. It is a huge energy generation from about like 1.5 megawatt solar power plant they have installed there. So friends, when we talk about like net zero, 85% of the requirement should also come from the renewable energy. So what they have done, they have some purchase power agreement, and that power purchase agreement is done with some RE vendors like renewable energy vendor, and that vendor is supplying about 14,260 megawatt hours of units of energy every year from these solar as well as the wind installations. So this is one of the good examples where huge energy is imported through the wheeling. This is the last example where a small size building which has gone for net zero energy certification it is a training institute from ICICI Bank. They have some collaboration with some institutes, and they provide skill development for unemployed rural people also. So primarily they have reduced the energy consumption by putting some of the passive features which are part of like a building envelope as well as like orientation also, and then remaining energy which is much less now. They have also reduced this energy consumption by putting the high energy efficient fans, DC fans, and also the phytoremediation system, which is like water treatment system. Instead of going STP, which will have a lot of machinery and fan system, blower system, which will continuously keep on consuming the energy. They have gone for like phytoremediation where there would be no energy use. So first they have reduced the energy consumption by design, and whatever remaining energy consumption is there from these operational energy equipment also, they have put about like 30 kilowatt peak of on-site rooftop solar system, and that is meeting the 100% requirement for the building. So friends, for research institutes, it is not like they should be part of like every green building certification, but they will go for several research. You may find lot many areas for green buildings which are especially good for like research. We can discuss after this webinar also, because I have another call at 11 o'clock. Then with regard to advancing zero, already we have discussed like this is a big terminology. Here we talk about like energy, water, waste, and finally net zero carbon. There are several opportunities of research, and in India is not done a good amount of research on these fronts. Then one good topic is like embodied energy. It has become very much popular in the market today. Embodied energy means whatever the product or equipment we use, we need to have the complete life cycle analysis for that, and we need to go for like cradle to cradle approach. We should have every component consideration in the energy use, and finally we can estimate like which product is good, which has like lowest embodied energy also. Then there are good research requirements on like building performance benchmarking. I think whole India is lacking on that front, and you can contribute if you have active faculty and student members here. So the sum is like there is a huge opportunity with regard to energy efficiency and renewable energy for this kind of new buildings, which may go for like net zero certification also. And while going for certification, it is not a big matter for that building, but they will have huge operational cost saving in that. This operational savings through energy efficiency or on-site, off-site RE will contribute in the huge savings, and they would be very happy with this kind of like cost savings in the project. So we also provide a lot of support for several projects in having this kind of certification. We are having some project from Sakti also. There we do several capacity building program, and this is part of that Sakti project. So thank you very much. If you have any doubt, please feel free to contact us. And we have Raghavendran sir. You may contact him for any support required in this front. And my colleague Vivek and myself would be very happy if you have any doubt. If you need any clarification, even after this call, we may contact you, and we can have call. We can discuss about all these opportunities. Thank you very much for this wonderful opportunity.
Thank you, sir. Gokul, can you post the questions, queries they have asked? No, can you post the questions to sir so that he can answer the queries?
Sir?
Yes, please.
Yeah,
So
one minute.
first- Okay, so first question, what is the addition, approval and challenges faced to achieve net zero energy building? Whether India achieving towards net zero energy target?
No,
What do you
can you
say,
repeat the question? What is extra what? Extra cost, is it?
Yes, sir.
See, see, net zero, like all buildings, when you see green buildings, the beginning, in early 2005, 10, 2010 and all that, the availability of green building products were very limited, and therefore the costs were high. But today the green building market itself has become a substantial market. Lots of buildings are aiming to achieve green. Lot of establishments take a policy that their buildings shall be green and sustainable. Therefore the market has grown, and because of volume the prices have come down. Now today, if you look at solar, the price of solar panels for generating electricity, on-site electricity, has been very high, and it's steadily coming down. And therefore, it's a question of supply demand. If there is a greater demand, like people are realizing today that you can get, economy of scales, and therefore the product will go up. And right now, if the net zero energy buildings cost a little high, but in a matter of time, it will become almost nothing. This is only in so far as tariff cost what we save. But in terms of buildings, what we have to do for the buildings to become thermally efficient and provide enough insulation for against heating loads and cooling loads and so on, that is without cost can be done. It's automatically part of passive design. So passive architecture is not an expensive architecture. So if you resort to passive architecture, you can almost reach quite a bit of the way towards net zero building.
Okay, sir. So next question is, net zero building is possible in cold areas or not?
Of course, it's possible. In fact, colder countries, here our problem is because of high temperature and tropical climate, and summers are severe, we have a requirement for air conditioning by way of bringing the temperature down to comfort levels. But in cold countries, it's exactly the reverse. They have to heat their buildings. They heat by various fossil fuel, they heat with electricity, they heat with better insulated buildings and so on. Therefore, that again consumes enormous power. Therefore, cold countries also, it is possible and is actively pursued in Western countries, the use of solar based or wind based alternative renewable power. And in fact, a country like some of the countries are so advanced in wind power, particularly some of the Scandinavian countries, there practically a substantial portion of the requirement is on wind based. And in fact, in India, Tamil Nadu is the forefront of wind generated power because of natural geography. There's a lot of wind corridors which provide possibility for wind generated areas. Now you will ask a question, what happens when there's no wind? Or what happens when there is no, when the sky is overcast? For instance, the sky is overcast, the solar system will not be working efficiently. Now, that's why a combination of these factors are taking place. In fact, they have gone to even further extent of exploring, for instance, ground tunnels, earth tunnels. Now, it's been realized that below the surface of the earth, about 4 meters or 5 meters below, the temperature remains constant irrespective of the climatic condition at surface level. Because the Earth's insulation, the thickness of Earth keeps insulating the conditions, whether it's summer or winter. Therefore, drawing, for instance, you want to cool the water from the cooling tower of an air conditioning system, you pass it through a tube at that level. You can replace the cooling tower, you can have a ground source cooling for the circulation of chilled water or the condenser water. So like this, a lot of natural possibilities are being examined. And of course, the good old hydraulic power that we used to generate. Hydraulic power is an absolutely a natural process, and it is it's a renewable energy in some sorts, but not available to all countries. So by combination, the countries choose what is best for them. For India, solar is the best, and wind is to some extent.
Hello, sir. Can I ask next question, sir?
Yeah, please.
Is there any net zero project
Say it again, please.
Is there any net zero project is going on in?
In fact, see, there is a yeah, no, there are buildings which are also if you take the office of the what is Environmental Ministry, which is the Paryavaran Bhavan in Delhi. It's completely net zero building. One of the first buildings in India to be net zero. It's got a huge, solar potential to generate power, and they are absolutely self-sufficient. And there are several buildings. For instance, in Chennai itself, a couple of years back, one of the TVS companies, Brakes India, installed a turbo energy factory. They installed solar collectors, and through the use of a particular system of air conditioning, the entire air conditioning load and lighting loads were met with solar. This was almost about 8-9 years ago or 10 years ago. So there are plenty of examples. There are particularly houses which are completely reliant on all renewable energy and so on. In fact, in Chennai itself was one of the first net zero homes. In fact, we were trying to. In fact, Vivek is trying to get that person also to come and talk. One, Mr. Rao, but he was busy. So there are plenty of examples. And perhaps off this webinar, you can probably have a session with Mr. VKVR Rao, who has done a net zero building. In fact, even disposal, it's zero discharge. It's completely recycled. It's a wonderful initiative done as early as about 10 years ago. There are plenty of buildings which are aiming towards net zero. In fact, some of the corporate offices that we are doing, particularly in the area of IT field, they on day one, they tell us we want a net zero building. So that makes it easier for us to design, start at the design stage itself. Instead of doing it as a retrofit at a later date, on day one, if you know the client's objective is to reach a net zero building. And the clients are very well aware of the cost. Even if the cost is a little extra, they know that the consequent savings that they produce in a matter of life cycle analysis, that they will eventually save. For instance, the extra investment that they do in some of the net zero possibilities in building, net zero opportunities in building, after 5 years, they're paying nothing. It comes free. Entire power comes free to them. So that's why it's a matter of choice, and plenty of companies have realized it, and it's become. I'm sure, Mr. Shivraj, Dr. Shivraj also agreed. In a matter of 5 to 10 years, you will find that clients coming to you as architects. When you're in the field as professionals, they'll come and tell you, we want net zero house, we want net zero office, we want net zero factory, we want net zero hospital. And these are all days not far off, and therefore it's very timely. This opportunity is available. I request all of you to pursue and go through the efforts done by IGBC. Try to learn them, take additional training courses, and in fact take the exam, accredited professional exam, and equip yourself, because this knowledge is going to stand by you in future years in your career. Thank you.
Okay, sir. Thank you, sir. Sir, it's a valuable session to the participants, those who are here. I would like to thank Padma Shri Raghavendran sir and also Dr. Shivraj Daka sir for this wonderful presentation. And I would like to thank Mr. Vivek sir to arrange this type of programs to make us to get knowledge, more knowledge on this, sir. Thank you so much to the participants and all. Thank you, sir.
Yeah, thank you very much, sir.
Thank you, sir.
Thank you very much.
Thank you very much, sir.
Okay.
I thank
Thank you.
Vivek sir for coordinating and completing this webinar. Thank you very much, Vivek sir.
Thanks a lot, ma'am. Thanks a lot for the
Thank you,
opportunity.
sir. Raghavendran sir. The
Thank you very
informations
much,
are very useful, sir, and our faculty will pursue some more projects on this, I hope. Thank you very much, sir. Thank you.
Thank you. Okay. Thank you. Bye.
Hello.
Sir, soon, sir.